Thank you, thank you. Are you ready? I'm just going to say this ahead of time. As I go through this presentation, I've got over 45 hours in putting this together for you. I created this for two reasons. One, to give you in-depth knowledge about essential oils so you realize that it's not about picking up the phone, calling a mail order catalog, and ordering an oil, and whatever it comes and whatever it says on the label is so. Because we know for an absolute fact it isn't so. Adulteration in the essential oil aromatherapy industry is probably the biggest and largest adulteration in the world in any industry. And why do I say that? Because there is no regulation for it at this time. That is one of the reasons that Eris Foundation was created, is to establish certification and regulation that is accepted by the government. And why do I say that? Is because I was told that if someone didn't do this, that had authority and the knowledge of essential oils, that the government would wind up putting sanctions and regulations on it. And I was told by these people who were from the FDA, Dr. Young, you're the foremost authority in the world and everyone recognizes you as such. If anyone should create a certification, it should be created by your standards. And if it's not, we will be forced to do it. So they know what's coming and we know what's coming. We know what's happened to the herb industry, don't we? Okay, because of what's happening and what's going on in the world, and everyone in Young Living needs to have this information, needs to know it because of what's going on right now. So why is Young Living the #1 choice for essential oils in the world? Where do you find the highest quality beyond the label and marketing hype? And many of you, you know, in the early days, you didn't have pretty labels on your bottles. Mary was the creator of the pretty and the beauty. I was the creator of that which is internal. But where do quality and purity start? Does it start with a broker, with a vendor, with the marketing, with the salespeople, with the lab and chemist? What determines a genuine therapeutic oil? God's creation with man's management. That's what creates an essential oil. Every organism created by God contains DNA memory, containing the blueprint for the production of that essential oil. Step 1, it starts with photosynthesis. It's very simple. The electromagnetic energy from the sun that combines within the plant, stimulating the chlorophyll to produce carbon dioxide combined with the sugars. And you see right there, and we call it bricks, and that's where we measure it. It's that chlorophyll liquid mixed in combination with the rain or the moisture, and the carbon dioxide from the atmosphere starts developing the sugar, and in that liquid is what we can take out and measure. Is called bricks, and it's really just the glucose of the plant. Okay, the sugars, they convert to fructose. 3 C's combined with the enzymatic secretion within the plant creates the 3C isoprene units that becomes essential oils. It all starts with photosynthesis. Proper cultivation, nutrients, crop rotation, soil building are required by the plant in order to produce an essential oil that harmonizes with the body chemistry, creating spiritual awareness and emotional stability. Poor farming practices produce low quality oil, and this is one of the areas where we see a lot of it. Farming, we think, is the best. The very best would be wildcrafting. And I will show you some things and let you decide if wildcrafting is the very best in every case, because I can tell you it's not the best in every case. Poor farming practices, the people growing the plants and distilling in these poor countries don't have adequate equipment. They cannot afford to do crop rotation. They cannot afford to do summer fallowing. They cannot afford organic farming, and they cannot afford the expensive fertilizers. And so they plant it, they grow it, and whatever they get is what they distill. And whatever they distill, they try and sell it. And lo and behold, there is a buyer out there for every drop of an essential oil, regardless of its quality. Because the perfume industry many years ago realized, in fact over 100 years ago, when they first started synthesizing compounds in 1878, that they could take the compounds from an essential oil, and many of them, even back 100 years ago, they could start duplicating them like a phenol. Well, now today, 100 years later, they can duplicate every molecule in every essential oil that they can identify. We do have compounds that have not been identified yet. So they'll take these substandard oils, they will take them into a lab, they will manipulate them with synthetics, or they will even take compounds from another oil. For example, like lavandin. Lavandin is the greatest structured oil in the world. And they take that and they'll structure it. Well, they'll borrow compounds from geranium that's much cheaper. Or they'll borrow compounds from eucalyptus or citrus, citronol, and citronella, which is a very common compound that contains some linalool. And they'll put that in there because it's much, much cheaper. Pennies on the dollar. And then they'll add some synthetic with it to structure it to make it look like lavender. And they will label it and brand it as lavender. These substandard oils enter the marketplace simply because that lower cost. And that's how they get there. It has a greater appeal to the marketer, who then sells them to the unknown public. These oils are sold as perfume oils and household goods, cleaning supplies, and cosmetics. There are different ways to manufacture and adulterate oils. Adulterated oils are very difficult to detect. In fact, can you detect them on a GCMS? Yes and no. What do I mean by yes and no? You run an oil through a GCMS, it does not tell you if a phenol is synthetic or natural. It doesn't tell you if a bronyl acetate is synthetic or natural. It doesn't tell you if linalool acetate is synthetic or natural. All it does is show you how much of it is there. Only a very well-trained analytical chemist can look at the compounds and go, wow, that percentage ratio is not right, something is wrong. But if you don't have an analytical chemist that knows how to look at that GCMS printout and know what those ratios should be, they won't know it and they won't see it. Number two, if that analytical chemist does not have the right instrumentation in his equipment, he will not see it again. You cannot analyze essential oils efficiently. Let me clarify that. You cannot analyze essential oils efficiently with one single 30-meter column. In my GC in Ecuador, I have two 60 meters and a 50-meter column in there for analysis. This 160 and 150 just for the GC, and 160 dedicated to go straight to the MS. We have the most sophisticated equipment that exists for analytical analysis of essential oils in the world today. So because of this, I build a team of people around me, the best in the world. And where did I get my knowledge to know how to do this? I started studying in 1994 with Albert Vieille Laboratory in France. In Grasse, France is where I took my first class in analytical chemistry. Then I went to Lyons, France and studied with Dr. Casabianca, and his name's right there. Dr. Hervé Casabianca has spoken from this stage and will again next year. He has been in my laboratory here in Utah 4 times training, and in Ecuador training there as well. And I have traveled to France and studied with him over 5 or 6 times over the years, continuing updating my information. I've taken 2 of my technicians there, actually 3, to train and study with him. So this is not something that I take lightly. I take it very, very serious. The other doctor I studied with was Dr. Hans Bashir from the Anadolu University in Eskişehir, Turkey. I went there and did 121 class hours in GC mass spectrometry analysis and understanding essential oils. Okay? The other thing that's really important, I have Dr. Richard Carlson, Dr. Cole Woolley, all of these people working in the laboratory, and you'll see them, to understand and determine what is the right percentages of compounds that should be present. Can you usually determine the ratios of percentage of an essential oil compound and detect the percentage of synthetics? No. You can only see that those percentages are not justified. Then you have to go back and use other instruments to determine if it's synthetic or if it's natural. And then you can come back and you can run it again and you can separate it. Once you identify it, then we separate it. And then we can see the optical rotations and the MRI and all the different things that we do for identifying if a synthetic is there. Do we do it alone? No, we don't. I work with 7 other laboratories around the world in identifying a compound. When we have a question, we have a suspicion that something is not right, it goes off to the other labs and we let them break it down because they have far more experience than I do. But combined with Dr. Woolley and Dr. Carlson and myself, combined we have over 125 years in study of analytical chemistry of essential oils. So I think we know what we're doing. Okay? There are other instruments that we use, and I'll talk about those as we go along. I trained with Dr. Hervé Casabianca in France, Rodwin Farag in Cairo, Egypt. I went there 4 different years and trained with this man in GC, mass spectrometry, and bioorganic chemistry in developing my background. Dr. Hans Bashir at the Anadolu University in Eskişehir, Turkey. Dr. Cole Woolley, Young Living Analytical Chemist, Vice President of Global Science, is also trained with Dr. Casabianca. Natural identical oils are made entirely in the laboratory and are used mainly in cosmetics and food flavoring. However, they're greatly migrating into the essential oil aromatherapy industry because there's so little knowledge about it. There's Dr. Casabianca sitting there beside me, training me in my own laboratory in Guayaquil, Ecuador at the farm, and everyone who's visited the farm has seen this laboratory, and those who are yet to visit will see it when you do. I don't just take it out of the closet and set it up for view and then take it out and put it away or give it back to the university where I rented it. And why do I say that? Because those are some of the stories out on the street. But Gary just rents the equipment, sets it up, and takes a picture, and then gives it back to the university. Yeah, well, talk to my accounting department and ask them how much money they have paid for my equipment. Okay? Here I am in the laboratory with Chris Packer, who we train as an analytical scientist. There's myself with Dr. Hervé and Cole Woolley in his lab in Lyons, France, 3 years ago this November. There's Dr. Hans Bashir, my professor that I trained under at Eskişehir, Turkey. We were speaking together. Guess where we were speaking together 2 years ago? West Cape, Africa, on essential oil chemistry. Why did I get invited to come there and speak? Step number 2, proper seed species. This is another area where we can have a genetic change. How do you know you have the proper plant species unless you're growing or working with the grower? And if you don't understand plants, how are you going to understand the seed? How are you going to understand and know what to look for in the genetics or the species of the seed that you're choosing if you're not a farmer? What is the origin of your seed? How do you know that the seed is not GMO? Okay? I look back over my life and I say, you know, I think God has something to do with where I'm at. Because one thing that I can tell you is I didn't consciously choose this path. What I was doing before my accident in 1973 is what I consciously chose to do, because I grew up on a ranch. I grew up ranching, farming with my father. I went to Canada and homesteaded in 1967 and developed a ranch there, running cattle and horses and logging in the wintertime. That was because it's what I knew and it's what I loved, and that's what I want to do the rest of my life. Somebody else had a different opinion. And because I wouldn't listen, he had to get my attention with a tree. Most seeds is commercially grown in a nursery. And if you go to these big seed companies, they've got huge greenhouses where they grow the plants to cultivate, gather the seed so they can sell it commercially. Can you imagine what it would cost to go out and wildcraft in the United States and try to gather seed from yarrow plants in the United States? Or fleabane in Utah? Yeah, it's cost prohibitive, and that's why there's commercial companies that grow it. Okay? Plants need the natural harshness of the environment to produce good seeds, which in turn produces good molecules of oil. This is where I first started growing in 1988 on a little quarter acre in Spokane, Washington. Where did the seeds come from? I brought the first seeds back from France in 1985, and I started planting in 1987. In 1988, in 1989, I just kept planting each year a little bit more and experimenting and growing. And this here was my first test plot of lavender in 1988 that we distilled in 1989, that I sent the oil to Dr. Kurt Snaubel, who is a PhD in biochemistry. He analyzed it. He sent it back to me with a note on the bottom and says, Gary, where did you get this oil? It's the best I've ever seen. I called him up on the phone and I said, Kurt, I distilled it right here. I mean, I was so excited I couldn't sit still. Can you imagine me getting excited over producing 1.5 milliliters of lavender oil? I mean, we produce thousands of gallons of it now, but I got excited over 1.5 milliliters of oil. And I said, well, Kurt, I distilled it here. He says, what do you mean here? Where are you? I says, here in Washington. He says, no, Gary, where did you really get it? And I says, Kurt, I grew the plants here. I distilled it here. He says, Gary, no, there's no lavender growing in Washington. And I says, well, as a matter of fact, there is. Well, finally, he says, golly, I didn't have any idea. He says, Gary, for real, you did this? And I said, yes. He says, this is the finest lavender I've seen. Finest lavender I've ever analyzed. Well, it was his fault that we are where we are today. Because if he would have come back and said, this is the crappiest stuff I've ever seen, well, I'd have hung it up right there, okay? First lavender seed came from France in 1985. Then I continued bringing in seed in 91, 92 that was planted in Mona, and then the plants and the seed went to Utah in 1996. And the rest is history. That's a picture of me in my field, 1998. This is where our clary sage seed came from. The original clary sage came from France, was planted and grown, harvested on the farm in St. Mary's from 1993 to 96. I finally gave up because the deer was my biggest competitor. They love clary sage. And what's really interesting, after a study that was done with the Fish and Game, we found when the deer eat clary sage that the does produce more twins. Unequivocally, more twins. Okay. Today, clary sage is grown at the Young Living Farm in Utah. You'll see it tomorrow. It's all going into bloom. It is magnificent. You will get to see chamomile being distilled tomorrow. You'll get to see juniper being distilled. You'll get to see it really done. The lavender's just started. It's a little late this year. Melissa. Where did the Melissa come from? It came from France in 1991. Why did I bring seed from there? Because I was able to go to the farms and get seed from the growers that were growing it in the field. It wasn't GMO, it wasn't genetically modified, and it wasn't grown and produced in a greenhouse. Now, whenever you take a seed and you take it from one place to another place and transplant it, then you have an adaptability process it has to go through. You know, and I heard a statement made by a person from another company a few weeks ago that said, oh, Young Living's plants are not genetically strong because they're all brought from other countries. Well, guess what? Practically every plant in the United States came from another country originally. I mean, so, and it doesn't matter where it came from, it matters what it produces. That's what matters. This is a field in 1999. Mary loves running the swather, cutting Melissa. It's one of her favorite things, and the other one that she loves cutting is the wild tansy. She's a fabulous swather operator. She found another niche in life next to singing. This picture was taken last year. Today, Young Living is the largest producer of Melissa oil in the world, over 100 acres in St. Mary's. How many have been to St. Mary's in the last 5 years? Wow, yes. How many are going this year? Me too. All right. Well, it's exciting because it is. It's beautiful. That machine right there, I designed that. We built that for harvesting Melissa. Because those of you who were there a couple of years ago knew that it took 18 people and 2 swathers 2 weeks to cut the Melissa fields. Because I will not let the Melissa touch the ground. So I designed this machine. We started building it a year and a half ago. Put it in the field last year. Had to make a few adjustments. But 3 people cut the entire fields in 3 days. So what does that do for our oil? It gives us better quality because when you're producing oils, you only have a short, small window for the harvest time. And if you go past that window, then the oil structure will start changing. The molecule percentages will start changing. So it's about doing it at the right time, peak time. And here we're gathering seed. This is a practice that goes on all over Ecuador. I send my farm crew not only over Ecuador, but into Peru, gathering seed. And here's pictures of them gathering Dorado Azul seed. So where does it come from? The seed was picked from the plants of the wilds naturally, brought to the farm, yes, and domesticated. Can you imagine harvesting enough wild lavender to produce enough oil for Young Living? France would have to grow 14.5 times bigger than it is now to produce enough wild lavender, and actually that wouldn't even do it. So what did I do? Knowing this, no matter where you go, no matter where you farm, no matter where your practices are, you're always going to have some deficiencies in soil because in St. Mary's there's a very acid condition. Aromatic plants will not grow in acid soil. So people said, well, that's ridiculous. Why are you doing it? You do what you do where you can with what you have. And I had the little farm in St. Mary's. And so what did I do? I spent years building and restructuring the soil and bringing the pH from 4.5 because it was a conifer farmland. There was only 35 acres that was in pasture and had not been plowed for over 40-some years. It was a cattle grazing summer pasture is all it was. Everything else was in timber, and now there's 200 acres in crop there. The soil was 4.5. Now we have an average soil of 7 pH. 7 to 7.8 is perfect for aromatic plant growth. So I took the soil, I planted in the first tray you see here, and then I planted some plants over here that we were experimenting with organic fertility program using microbes and enzymes. And so we did this whole test project. This went on for almost 6 years as I was looking at developing an organic fertility program that would feed my plants because I had one thing in mind. In order to develop good oil, you have to have good soil. In order to develop good oil, the plants have got to have roots that go into that soil. And I will show you now what I was talking about. Here's plants that we treated that did not have any treatment, untreated plants. These plants were treated with our biogenous fertility, And these plants here were treated with both frequency and our biogenesis fertility. And so I started at that time, clear back in 1992, looking at frequency and how it affected the seed. Now, we can't broadcast enough frequency in the field and be effective, but we can expose our seed to frequency. So we would treat the seed with frequency, then we'd start our starts in the wintertime inside the greenhouse, so we'd get a jump start on them to go in the field in the spring so they could take root. So this whole project produced this. And these are the original plants right here. In plant A, that did not contain any fertility. And you can see the leaf growth is smaller, but the root growth is much shorter. And we use frequency. Look at what happened. Just adding frequency to the seed. The difference in the leaf, the difference in the root structure. Just from adding frequency. That's all. Isn't that amazing? And then we looked at here and we did just biogenesis. Well, the leaves are smaller. We looked at that. And then we tried it here without biogenesis. And then here's where we combine the biogenesis with frequency and look at the root length. And folks, that's what produces the best quality oil that you have in the world. Because when those roots go down, how many of you know how long the roots are on alfalfa? An average of 21 feet. Why is alfalfa one of the highest plants in natural nitrogen? Because those roots grow down and they bring it up. Why is alfalfa one of the highest plants in nitrogen that converts to protein in your body? Because of that root growth. Why is it high in chlorophyll? Why is it a great antioxidant? Every one of you should be grazing on alfalfa, besides the cows and horses, okay? But this is the project. I've spent years in developing this, and I haven't talked about it too much in the last few years because this is old story. But I realize there's a whole bunch of you here that don't know the old story of how Young Living evolved and what brought us to where we are today. Now, is our competitors, are they going to take the years out of their life and do this? No. Because why? All they're interested in is money. They're not interested in developing something that's agro-sustainable, that's going to be sustainable for our environment and sustainable for your children's future. So Grow Healthy Plant starts with understanding the soil and the chemistry and the nutritional need of the plants. And I spent 6 years, we're still doing it, but 6 years in the original startup phase, and I'll show you what we're doing today. Because we have a huge research center at the farm in Ecuador. Why? Because we can work there 12 months out of the year. Insufficient soil nutrients will result in poor oil quality. Now, another thing that's important is geographical location, soil type, climate, elevation, humidity, temperature, sunlight, frost-free days, rainfall, many other elements determine the health and the growth of plants that produce quality oil. Step number 3, preparation. And those hands are not mine. That's a distributor, because we have distributors come every year that help plant, volunteer to plant, volunteer to harvest. That plant is planted with another frequency. It's called love. This was in 1994 when I was building the soil, and there I'm on my tractor injecting microbes and enzymes into the soil to bring the pH up and start reestablishing it. Yes, this is to grow aromatic plants, to produce good oil. It's not just a matter of going out and getting it from a broker. Then you're getting perfume. Here we're unloading a truckload of cow manure to mix in our compost to go on the fields. Oh my goodness, who would want to have an oil put in their cocktail grown with cow manure? Higher protein. All aromatic plants prefer well-drained soil. Heavy clay soils need to be composted. They need to be built up with humus, enzymes, microbes to break down the composition. Aromatic plants need nitrogen, phosphorus, potash, and a pH range from 7 to 7.8 to produce good oil. Compost increases nitrogen. Banana peels, coconut husks are fabulous, what we use in Ecuador for nitrogen. And here we use clover and alfalfa to increase nitrogen. We use worm castings to increase nitrogen and balance the phosphorus to build a humus in the soil. Here's one of our composting yards at the farm in Ecuador. We've got a composting yard in Utah. You can see it tomorrow. You can walk the 6 miles down there and back. No problem. No, it's not that far. It's a quarter of a mile down by the railroad tracks where our composting yard is. But that's just one of our yards. We have a composting yard at the farm in St. Mary's in France. Every farm has its own composting yard. And what goes into this composting yard? The material taken out of the extraction chambers. Leaves, grass, anything that's cut goes into that composting yard. Our farm down in Utah, we have a lot of animals. Where does the manure go? In that composting unit. We have a big machine down there that we lay it out, the trucks drop it off, and then a big machine goes over and just grinds it and mixes it together. We grind it here and mix it together, and then it's piled, and then they put the plastic over it so it can start sweating and developing that microbial action to break it down. Here's one of 6 of our big worm houses on the farm, where we not only create the worm casting, but we create liquid fertility. Because you know what happens when worms eat dirt? They poop. That's called castings. What a word for excretion, huh? Castings. Also, as that is breaking down, the enzymes, all of the digestion, all of the residue, it also creates a liquid. And that liquid goes right here in the holding tanks. We got 5,000 gallons. We got one for each 2 worm houses, that the liquid from the casting goes into these tanks right here. Then that liquid goes back on to the fields through the irrigation system, sometimes through spray units that you'll see. But we also do one other thing. Not only do we have, see that tank, that lid right there? That's another 5,000 gallon tank, because as the compost breaks down, it liquefies, and that liquid goes into that tank. So we take that tank liquid, and we take this liquid, and we mix it together. Oh my goodness, what incredible, incredible fertility for our plants, and it's all organic. And just as of 2 weeks ago, we received 3 organic certificates for the farm in Ecuador after 6 years. Okay? So this doesn't happen by going out and standing on stage and doing marketing hype. This is work. There's another one of our composting yards, and we do composting worldwide. There's the liquid, you know, and if you really want to have a jump start in life, you come to the farm and visit the farm, bring your cup and just get a dip and drink a cup of that. Whoa! Man, bones, muscles, tissues, just... And then you might throw it up. Okay, weed control, summer fallowing, new fields, planting cover crops, field rotation. Essential oils sprayed for weed control have proven to be very successful. I have spent, Mary can tell you how many years since you've known me, honey, doing this. Long as she can remember. 20 years, yes. Because I believe that if weeds would grow, there would be a weed that would control a weed. And so I went to work looking at it. Although essential oils are more expensive, they are better than commercial sprays. Oils used in the herbicide spray applications: cinnamon, Palo Santo, basil, Idaho tansy, pine, neem, and castile are the main ones we use. Now we're using Ecuador oregano as well. We found it has tremendous benefit on particularly the fungicides that grow on plants. All fields are sprayed with natural herbicide made with essential oils, neem, and castile. Roadside weeds, ditches are sprayed with Roundup, which is 12 times less expensive. We, unfortunately, live where there's neighbors, and we live where the wind blows. And all of their fields and the ditches and the roadsides around the farm grow weeds and spread seed. So yes, we spray those areas with Roundup because it's so much cheaper, and it's such a big area to try to prevent and control because of outside seeds, and there is no way we will ever be successful in controlling weeds. It's part of nature. So when you go down to the farm, you see a pristine field, it's because there were 17 or 21 field hands in that field hoeing those weeds. The fields that you will see weeds in, it's because the field hands haven't gotten there yet to hoe those weeds. So tomorrow when you see a weed, don't go, oh my goodness, I thought this was an organic farm where they, controlled the weeds. Hey, if we controlled every single weed, your lavender oil costs you $1,000 a bottle. Okay? We have to be real about it. Now, there's another factor. Do some weeds get in the distillation? Absolutely. Because, our harvesters don't go out there and become selective. The cutters don't cut one lavender and then jump over the weed and cut the next one. But this is the thing with weeds. They all contain chlorophyll. That's why the plants have to shade dry, because chlorophyll will flash off within the first, generally, 2 to 4 hours. That's why we let the plants sit in the field up to 3 days and longer in some areas. So if there's any weeds in there, any grass in there, that chlorophyll will flash off, so it doesn't have any interference with the oil, okay? Commercial sprays are not used on young living essential oil crops, period. Irrespective of what the other people out there say, and I find it really interesting. How do they know? They've never set foot on a farm. Here we're spraying essential oil application. This is what I said, hand spraying. Why? Because this is Ecuador. We can afford to do hand spraying for spot areas. And this happened to be one of our basil fields. Here they're fumigating again, and this was a mixture of basil, Palo Santo, and tansy. Because of the white flies, we have different pests in Ecuador than we have here, or Idaho, or France, or even in Oman. Isn't that fun? And now we're filing a patent on my design and development. So now we can produce more Melissa quicker, so that enabled us to expand our fields, double, triple, quadruple our fields, because now we can do it affordably. This is a weather station. We have a weather station on our farm in Ecuador because there are not weather stations there. It's not like here in Utah, there's weather stations all over the state, so we can tap into that to get the information we need. But we didn't have that in Ecuador, so we established our own weather station. What do we use that for? So we can measure the barometric pressures, the humidity, the temperatures, the UV, daylight hours, the dark hours, the rainfall, everything that has to do with weather, even the wind and wind velocities, everything is measured with this weather station, and it's recorded every single day, 365 days of the year, and goes into our computer banks in the office there. And then my distillery crew takes that information. My nursery crew takes that information and puts it together, and we're developing charts that you're going to see now as we're putting all this together after having 5 years running with the weather station, showing how the weather and temperatures and the UV lighting will affect the bricks and the harvest time for the plants. This has never been done anywhere in the world except at Young Living. Yeah, I didn't need to spend money on this. I didn't need to spend $3 million on labs. I didn't need to spend money on farms. I could just put all that into marketing hype, and you wouldn't be any better. Thank you. This is one of our nurseries on the farm in Ecuador. And here's where we record the root growth, the adaptability, pest resistance, weed control. We also study new plants found in the jungle, the water needs for the plants. The future potential for oil production is in this nursery. We have a whole computer system here that every day all that information is recorded in the computer. So I can access it whenever I need to and look at it to determine what we need to do. You can't really see them in the picture, but right back there in the background are 2 large 6-foot glass boxes where we take our seeds that we're not familiar with, we plant them in there, and we study them, and we measure, and we watch the root growth. We did this when we were studying and developing the weed control formula, which oils affected the weeds. So when we'd spray it, we could watch and see if it was going down into the roots and killing the roots, or all if it was doing was just burning the tops, because the first couple of sprays that I made for weed control in St. Mary's, all I did was just burn the tops of the weeds. It didn't get down into the root. And why? Simply because I wasn't using a surfactant like neem and castile to hold the plant so it would be taken down into the root. So I'd spray the oil, it would burn the leaves, and then it'd flash off. Oh, it's been a learning process because nobody has ever done this before. Yeah, makes you tired sometimes. Oh, here's our oregano in Ecuador that we developed. And this is what I was really excited about. Over here on the right column, this is our traditional Turkish oregano. And here on the left column is our oregano that we grow in Ecuador on the farm now. 21 more compounds. And when you look at the carvacrol right here, this is where you get exciting, for spinal structural conditions. And I discovered this in 2006 when I just distilled some of the oregano in our lab distillery that I first started with down there. I had a 150 liter and a 250 liter, and that's what I started with. We distilled it, and I had to send it home to be analyzed, and I used it, and I put it on, and what was amazing, the first revelation was there was no irritation. It wasn't uncomfortable, because carvacrol is hot, and if you don't use the right application, and particularly if there's inflammation in the tissue, it'll get hotter. But the Ecuador oregano didn't create that reaction. So yes, I'm very excited about what we've created in Ecuador. Very excited for our future because we have something that no one else does. Young Living is the only one that has this oregano oil in the world. Now there's a picture of the plant. Determining the perfect time for harvest the crops. We did the following. Watch the sugar, the bricks, in the plants and test the oil level compound percentages. So when I'm working with new plants, like Dorado Azul, for example, because it just grew in the wilds one time a year, we brought it to the farm, domesticate. We had to learn how to domesticate. We had to learn the characteristics, its behavior, to see if we could do more than 1 year harvest. Now, 7 years later, we're able to harvest Dorado Azul 2 times a year. So in the meantime, I had to know where and when the oil was there. So we'd cut Dorado Azul, we would distill. We would cut Dorado Azul, we would distill. We would cut Dorado Azul, we would distill, cut and distill. And we would do this from the moment I saw it starting to develop, the pre-bud, all the way through the budding stage, the flowering stage, post-flower, and seed. And final seed to where it dropped on the ground. So we were distilling Dorado Azul sometimes during that first stage 2 and 3 times a week as it was making those changes to determine where was the best oil percentages at. So it's all work. Watch the behavior of the plants, determine their needs. Sample, distill to determine the right distilling time. So how much time do we keep it in the distillery? Do we distill for a half hour, an hour, 2 hours, 3 hours, 4 hours, 5 hours? How much time do we use? Tested dried plants to determine when they had the highest level of oil for distillation. How much time do they leave them on the ground? Do you leave them in the sun? Do you leave them in the shade? Do you let them dry 10 hours, 12 hours, 24, 2 days, 3 days, 5 days, 7 days? Because all the climate in Ecuador is different. So it was a whole learning curve. And people say, well, Gary, what did it take you so long? And then they expected me to travel and attend convention and teach seminars. And so here's a sample. St. Mary's lavender, shade dried for 62 hours. Brix at 24 before we distill. Mona shade dried for 48 hours. Why? Because the temperatures in Mona are hotter. All right, Brix will hit 28. We've had Brix hit as high as 30 with lavender and Mona before we distill. France lavender, cut before flowers go to seed, dried for 76 hours. Laying in the field. In the old days when I worked in the field and with John Nell, the cutters would come and they would spit the bundles right out, right on top of the cut plant. And then 3 days later, we'd come behind with wagons and a pitchfork and pitch them into the wagon to go to the distillery. Out of the field that had been cut and laid in the field for 4 weeks before it got to the distillery. Now, that wasn't a traditional practice. That was because they got rain on it. So they'd leave it till the rain had stopped, and then it'd rain some more. And it took them 4 weeks before it finally dried enough. They got it to the distillery to distill, and it still produced good oil. But the best time is right here that I'm sharing with Melissa. Cut at mid-bloom and shade-dried for 12 hours maximum. Brix 14. Oregano, cut before going to seed, shade-dried 120 hours. Brix 24. Dorado Sul, cut and distilled immediately. Brix at 16. Frankincense, Oman, cut resin, matured 125 days before distillation. Peppermint, cut in full bloom, sun-dried for 3 days, Brix 28. So, has anyone else ever done this that you know of, Jean-Noel? And here's a group of our people that wildcraft for us. And some of you don't know this, but between Ecuador, the farm, our people in the mountains, our people in the jungle, our Peruvian people, we provide a living for over 2,000 people in Ecuador and Peru. Young Living Tree Farm in Naples, Idaho, where we harvest fir, pine, cedar, balsam, and blue spruce. Here's a distillery in Ecuador. Here we have the plants laying on the floor, under the roof, shade drying, and here Eugenio is, he's gathering plants. He does this every 2 hours, testing the bricks every 2 hours. And not only when they test the bricks at that 2 hours, they take a batch down, put it in the small 150-liter still, and cook it. And take that oil upstairs to the lab and we analyze it. So we have a complete record of what those plants are doing every 2 hours during the 12 hours of daylight. This is when I was in Madagascar teaching the people, where this lady here in the red had just built a bush distill for distilling vetiver. And they were getting ready to distill it, and they didn't even know what they were doing. They didn't know how to distill it. They didn't know how to compact. And the other thing, she had built this distillery and put a valve on the swan neck to close it. And I said to her, I said, what's this? And she says, it's a valve to close it. And I said, why? And she said, well, I was told I have to have pressure in the still in order to get the oil out. And I said to her, I says, you are so lucky that I'm here. Because if she would have fired that distill and it would have built to 1 pound of pressure, it would have gone off like an atomic bomb. And anybody within the proximity of that building would have been likely killed. And so here, we took the lid off, we unpacked it. I started then showing them and teaching them how to separate the roots and to chop them and get them in and compress the chamber right. We took the valve out, and now she's producing vetiver oil. This is our peppermint field in Utah. And here's the bricks. And this is another thing that I've done that's very interesting. You look at these columns and we go down through them. And here's minimum maximum ranges that we use that are basically our standard ranges that we have adopted as we've been building ours. And we start looking. So I started distilling on August the 12th. And then this was later in the afternoon on August the 12th. And on August the 12th, we took another sample. All the way up from when we started on August the 12th of pulling samples until we went clear through September the 22nd, pulling samples and distillation of the peppermint to get to the point to where we had the finest quality peppermint in the world today, without question. And as we look here, there's methone, 9.35%, methyl, 60.7%. What ranges do the peppermint companies want peppermint oil, they wanted over 45%. Menthol is where the money's at if you're selling it. What does menthol do? Menthol is your penetrating compound. That's the one that drives in. It's the personifier of peppermint. It's what makes everything else work. And how did we know this? You only know this by distilling it every single day for 4 solid weeks to determine. And why? Because peppermint oil has never been grown above 4,500 feet in the United States before. In Idaho, there's a grower there that grows at 4,200 or 4,300 feet. He never distills his peppermint. And I went and visited him. I said, why? He says, because I can't produce menthol at this elevation. I said, of course you can. He says, no, I can't. I've tried it. So he just grows peppermint and just sells the roots to the growers. Doesn't know what he can do because he never did this to find out. There's a difference, and I'll get to that here in just a minute, because there's a lot of things that takes place in order to produce a good oil. You have to take into consideration. Here's a peppermint oil that comes from a competitor, and they swear up and down it doesn't have it in there. So 7 labs identified these. It wasn't our lab, okay? Limonene at 5.4. Where's limonene? It should be right here, around 1 to 2. 3 is high. So what does that tell you? Something's been added to it. You look down at the bottom, ethyl vanillin, a complete synthetic. They use that as a flavoring agent. Why do the oils smell sweet? Because they put sweet-smelling synthetics in them. Simple as that. And it makes them cheap. We look at this, and methyl acetate. What's wrong with that one? 1.93. The methyl acetate is way too low for peppermint oil. So what does it mean? It's a structured oil. Very simple. And when you can understand how to read a GC and you understand where those percentages should be, it makes it easy for you to realize that something is wrong. First thing you do is teach your nose how to smell. Once you smell, and that's what I do, I smell it and I said, it's no good, analyze it and see what's wrong with it. Now here's something else that you'll find interesting. Eucalyptus. This is one tree that produces 2 oils. When it's 2 years old, it produces blue gum with azolene in it, eucalyptol at 52%. But as it matures past 2 years, and you see it right here, see the little difference in the leaf, here and here? This is Eucalyptus citral. And so that tree, after it goes past 2 years, it goes through a transformation change, and you get 2 different oils from the same tree. Does anybody recognize this guy right here? That's my partner. John Well, stand up. There's a lot of folks here who don't know you. Thank you, thank you. Well, John Well took our distributors and we went on the mountain wildcrafting. This is wild lavender right here. See it? It's all around here. Little tiny plants. Now, do you want oil from that, or would you rather have oil from this? Okay? So if we look at this, do you understand what I mean now? That France would have to be 14, 20 times bigger growing wild lavender in order to produce lavender for young living alone? It would be impossible. Wild lavender plants are very, very short. They're very, very tiny. Small spikes, smaller flowers. You know, the little bit of oil they produce, it's beautiful, but it's unrealistic. So this is a harvester I imported from France. That's Eldon Nettle right there helping me cut lavender. This is our greenhouses where we grow lavender. You'll see some of that tomorrow as well. And we grow an average of anywhere from 1 to 3 million plants every winter. And there's your lavender field in bloom. And you look at the different colors. The pictures, you know, don't do justice to it. But true lavender, it has colors everything from white to deep, deep violet purple. If you have hybrids, it's exactly the same. It's just like taking a kid and making a photocopy of them. Now here's my partner. This is Benoit, and this is Nicholas, John Noel's son. Jean-Marie, my partner, and Benoit's father has been the president of the Lavender Growers Association for a number of years. We just accomplished something last year that's been very exciting for us because we have merged our farms together to become the largest true lavender grower in the world today.
Hello, everybody. Yeah, I really would like to emphasize what Gary just told you. And I want to go back 23 years ago when I first met Gary. You know, all he's doing now, he was already speaking about it 23 years ago. He already had the belief that we needed very high quality therapeutic grade essential oils when nobody even knew what essential oils was. That means this is a true belief that never changed for 23 years as far as I am concerned. And 23 years ago, everybody was laughing at this guy. What is he talking about? Either they just wouldn't understand one word of what he was saying. Speaking about essential oils for emotional feelings 23 years ago, but first question, what is essential oil? Nobody knew about aromatherapy at that time. There was no aromatherapy businesses, you know, and this guy, when he came first, speaking with their fathers, you know, with me, We thought he was from another planet coming down here. What is he talking about? Now, that's why I really feel strong about all this. And, when I bring you Benoit, he's the president of the largest research center on lavender farming in the world, and he's coming for the third time because he knows he's learning every time something from Gary. And his father was learning something from Gary 23 years ago. So that makes this company unique, based on this belief from start that essential oils had a very strong quality, not just for physical purposes like the French aromatherapist doctor thought, but also on emotional levels and spiritual levels. And it has been Gary's teaching for 25 years now. He never changed that, and he knew he had to take big actions like he has been doing, spending millions of dollars, farming, distilling, researching on farming and distilling, to the point where nobody else can do the same. I get a little bit excited, but that's my age. So, I feel very proud that Gary accepted me as a partner. It's a very high position for me, and I am very happy to let you know that you have the strongest roots in this company than any other follower company on marketing, because it's a new fad. It wasn't at that time. And this guy, I've heard so many people criticizing him when essential oils were becoming known thanks to him. So they were attacking him. They were very, very hard on him. And we have to stick together as a company, as a family, to really make it and grow. So Jean-Marie, third generation of lavender grower, is the main guy who cultivates our fields. He also has a farm on his own of about 250 acres. And Benoit, as I told you, is also the fourth generation. His great-great-grandfather started the first plantation of lavender from wild plants to fields, in late 1800. Could you believe that? And he's also the president of the local Farmers Association and also the president of the Research Institute on, how to cultivate lavender the best way. And they really enjoy, and now they may have laughed about Gary 23 years ago, those guys, but now they really listen to him when he comes and visits, even those technicians and people with a lot of knowledge. But anyway, he has about 600 acres. So altogether, we can produce as much therapeutic young living quality oil as you need, thanks to this belief they have now in Gary and young living.
Thank you, thank you. So, with that, another round of applause for my partners and for the largest lavender growing farm in the world. Okay, this is just a chromatogram here of lavender, mass spec, and again we start looking at the falsification of the linalool acetates and the compounds that are added in here that do not fit in the profile and the standard of true lavender. And what this is nothing more than lavandin that has been structured. And as I mentioned earlier, and you look there on the bottom, there was compounds that were added like citronellol, methyl shavicol, acetyl linalool oxide, citronellol, formate, geraniol, gamma, eudicimol. These compounds do not belong in lavender, but they were found in the competitor's lavender that they called lavender. Structured lavandin, many of these compounds are found typical here in chamomile and geranium, and of course also found in synthetic form. But those are the things that we deal with. Here's the Mona lavender. Again, we go through, we look at the GCs and the compounds. We watch it every week. We pull samples through distillation and watch it to see, are we maintaining a very consistent profile in our oils through. And we can see profiles modulate a little bit just by changing the nitrogen levels. We'll change the percentages a little bit. So if the soil is deficient, you'll watch those percentages drop down, particularly in linalool acetate. It'll drop down if the nitrogen is low. You bring the nitrogen up, the linalool will come up. So it's all about understanding the plant, it's understanding the soil in order to produce the best quality. There's Dr. Casabianca standing in my oregano field in Ecuador. This is how it looked like the year before we cleared the land, because right here is where the ylang-ylang trees are planted now. And you came and we planted 240,000 trees there in 2011. The land was cleared and prepared, and that's what it looked like. That's the trees that are there today that you planted, taken on June the 9th this year. Isn't that beautiful? There's Laura picking ylang-ylang flowers last year, and today we have a whole picking crew that does nothing but pick ylang-ylang flowers all day long, 6 days a week. 6 days a week. Now we have, this is a ylang-ylang tree in Nosy Bay, Madagascar. Look at how scrawny the tree is versus this. Isn't that amazing? So which tree would you rather have your oil come from? That one or these? Look at that. Here's another from Nosy Bay. Look at the limbs here with no leaves, no flowers on them. Because the ground is so choked with weeds and grasses, the trees can't get good fertility. They don't have the resources to put composting on the field. They don't have resources for worm castings. They don't have resources for putting microbes and enzymes. If you're going to expect the soil to produce an oil, you've got to feed it. Just ask yourself, what would happen to me if I quit eating? Okay? It's no different for a plant. It's no different for an oil. You want it, you feed it, you take care of it. And so we look at the comparison between the Ecuador ylang-ylang and the Madagascar ylang-ylang, and it says for itself. And it's really interesting because you look at the benzoate right here. See the difference in there? 8.6 versus Madagascar at 6.7. So which one would you rather have higher? Well, that's a no-brainer. And this is what I do, and this is what gets my blood pumping and why I get excited and why I get so defensive about synthetic oils. And we look at these compounds. For example, right there, alpha-humulene, 4.2 versus 3. Reduces edema, prevents tumor necrosis, reduces production of prostaglandin from fatty acids causing inflammation found in prostate and urinary areas. Which would you rather have more of or less of? The ylang-ylang is an incredible oil for many reasons. We think it's just a great perfume oil. Well, it is a great fragrance oil. It is wonderful. You walk on the farm in Ecuador right now, and your heart would go, where's the man of my life? Where's the woman of my dreams? And the farm is called the Love Farm now. Can you imagine 45,000 trees emitting that incredible aroma 24/7? It's magical, okay? It's linalool. We look at the linalool about anticonvulsant, sedative, effect on central nervous systems, glutamate binding. I mean, incredible what we've created here in the comparisons because of the difference in the fertility program. Here's Dorado Azul. When I first discovered, this was the first year I planted it on the farm in Ecuador, and it grew 13 feet tall. The oil is absolutely fantastic. Step number 6 to producing a good oil, distillation. You know, 1, load the extraction chamber tight. Distribution of plant material in the chamber. Maintaining steam saturation at the right volume to keep the chamber hot to prevent homogenization of oils. Keep ramping the steam temperature and volume to prevent reflux. Knowing when to ramp volume, when not, in order to not flood the chamber and fracture the molecules. Listen to the sounds of the steam to know when it's time to ramp the temperature and not cause a chimney effect in the chamber. Know when the steam will break into the swan neck of the condenser. Know how to ramp without overheating the material and flooding the condenser. All of these are critical factors that are not taught in a school. Okay? Know what temperature is necessary to get maximum extraction from the plant material without damaging the oil. Example, lavender, 240 degrees. Balsam, 280 degrees. Frankincense, 260 degrees. Melissa, 220 degrees. Okay, how did I learn that? By doing it. Doing it. Know what temperature to keep the condenser while distilling. Example, lavender, 80 degrees. Melissa, 110 degrees. Know what temperature to maintain in the separator for different oils to assure the best separation recovery. Gary builds the first distillery, 1989. Second one, 1993. Oh, this was actually my third distillery, 1993. The fourth one, 1994. You see that little lady right there in the red dress? Guess who that is? That was a distributor. And she'd heard a rumor that there was no such thing as a stainless steel distillery in America. She wanted to check this dude out that was talking about essential oils. So she got on a plane, flew all the way to Spokane, and came out to the farm to see if it was for real. And you know what? I caught her out in the field planting clary sage. And that lady is Mary. So when I saw her planting, I thought, God, is there any chance? Is there any chance? Is there any chance? And then I was too afraid to ask. There's a distillery in Ecuador. 3 chambers, 14,000 liters each. This is a heat exchanger because in Ecuador you can't get cold water. You have to have cold water for good separation in the condenser because it has to go through a phase change. You can't have 80-degree water in a condenser where you're trying to create the phase change between gas and liquid. And so I had to build these heat exchangers to get my water from 82 degrees down to 50 degrees, and I built them out of deep freezes and put copper coils in them and filled them with antifreeze so they wouldn't freeze, and maintain my temperature now on discharge at 45 degrees for our condensing process. There's the separators I built. These condensers are 13 feet long, one heat exchanger for each condenser. Here's the distributors loading the cooker with fir chips. Okay, our distillery in Oman when I built it 3 years ago, and now we have another distillery. We've just added, as of 2 months ago, a third distillery to our arsenal in Oman, and the diamonds, crown diamonds, were there when the distillery arrived from the ship, when they planted their frankincense trees. No, this is not something that I'm standing up here telling you exists, but you can't see it because it's proprietary information. Everyone in this room, you want to see it, just get on your horse and go see it. Okay, you're all welcome. And you'll see it tomorrow in Utah. This was our next project we did in Jericho Valley. Man, is this exciting. 2 big greenhouses we've put up there for the growing of the balm of Gilead and other aromatic plants, as we're starting the process now of going forward, identifying the plants in Israel. And micromeria was the first one to come to you. How many got micromeria? Wow, did you like that? Isn't that amazing? Yes, many things you're going to see. We got a small distillery there. We got another distillery going in 2 months. Our first distillery we put up last year in September in Taiwan. Now we have 2 distilleries in Taiwan. How many of you liked your Hong Mao? Aren't those beautiful oils? Oh my goodness. Yes, precious. Okay, our 7th farm in Iquitos, Peru. Now, right now it's planned, and we'll make this announcement, but just make a note, we're planning, Mary and I, to be there around August 28th, 29th, that weekend, because we're going to have a ribbon cutting ceremony on the farm, the distillery. We're pushing to have it installed and ready to go, but we're going to do one more thing for all those that choose to come for this celebration. We're going to plant rosewood trees. Okay? So we've had a nursery in Pucallpa growing rosewood trees for us for the past 3. I started this whole project 3 years ago in Peru. I knew that I would have land. I knew I'd have a distillery. Why did I know that? Because I do it. And because of what we're doing, because we're starting the first reforestation project in South America ever in history for rosewood, because of what we're doing, we're growing it, because we're doing it. Idaho Blue Spruce. Distilled this for the first time a year ago last January. How many love Idaho Blue Spruce? Yes. My goodness. An energy booster. Wow. I won't tell you how it boosts your energy, but you'll find out. Laboratory analysis and research, number 7. Testing for quality compound percentages. Identify new compounds and oils while looking for quality and adulteration in vendor oils. And here's my lab. That's just part of my staff there. Dr. Richard Carlson, PhD in analytical chemistry, Director of the Research and Development, 25 years in analytical chemistry. Dr. Cole Woolley, PhD of essential oil research, 27 years, oil and plant chemistry analytical studies. Marilyn Pingar, quality control manager, over 15 years of laboratory analytical work with GC's mass spec. Dr. Chin, PhD, senior lab scientist. He's got 50 years under his belt as an analytical chemist for organic oils and plants. Do I have an arsenal of people that know what they're doing? Better, there is not another lab in the world that is more well-equipped than the Young Living Lab here in Utah, okay? Brett Smith, our analytical scientist, who runs one of the GCs. We have 3 GCs down there in that laboratory, okay? And now we're just getting started. All these other folks over here, I didn't have enough room to put all their names on. They work in the microbiology department, studying the quality control, studying your product, making sure it's the quality that you want. They do all the bacteriological studies on the oils as well. So it's not just the analytical chemistry part. We study every fraction of it. Here's some of the resumes of those, and we don't have time to read them, but this will be printed for you. I want you to know who's behind your work, who's supporting what we're doing here. You folks have something to be proud of. You have something to believe in. Okay? Dr. Cole Woolley, my goodness, he goes all over the world. I used to go in, I set up the project, then I send Cole in to do the work. You know, and that's where I'm able to get more done, because while he's in Taiwan finishing what I couldn't, then I'm in Jericho starting another project, or now we're in Egypt and in Peru. And I have these men that can follow behind and support me in this work. and we just keep going and growing. There's one room of the lab that has 3 GCs and a mass spec in it. Here's another room right behind Maryland. Right here is the UHLPC, ultra high definition gas chromatogram. What's different about that machine? It's taken me 20 years to get that machine because it costs so much money. That one machine was over $250,000. I didn't need to do that. I could have taken a bonus. But yes, I did need to do it for each one of you. So you know, when I say your oil is pure, that's not a guess. And I'm not standing up here telling you a bunch of lies. It's a fact. I've invested in your future, invested in your presence. There's another part of the lab. All of this is just the analytical part, where we carry out over 9 different tests just on the analytical chemistry of the essential oils. There's Brett sitting at the GC. Here's where we test our oils for gravity, velocity. Here's the bacteriology lab. And here are the tests that we do, and I'm sorry that's so small that you can't read it. But that's just a list of the tests that we do on your oils in our laboratory. And we do part of this in Ecuador. We do now part of it in St. Mary's. Dr. Casabianca supports that. Dr. Mahmoud in Salalah, Oman at the university. We do the testing there. Oklahoma State University with H.K. Lynn. It just goes on and on and on. Now, this is my staff here, the Research and Production Development Department. This is a whole nother department. And that's all they do is just work in the production of your products. Dr. Cole Woolley standing beside a GC talking about the optical rotation equipment for analyzing whether it's a dextrorotary or a laval rotary. Because if you look at a compound and it's supposed to be dextrorotary but it's laval rotary or vice versa, we know it's synthetic. But there you got frankincense that's got laval rotary limonene and you got citrus oil that's got dextrorotary limonene. So just because it's dextro or laval doesn't mean one's synthetic unless it's the opposite of what should be in the compound. A GC doesn't tell you the optical rotation. You have to have a whole other instrument to do that. We have an instrument here. We have the instrument in Ecuador for doing the exact same thing. So when I test an oil there and I send the results here, they either get the same test or something's wrong and we go back to the drawing board and figure out what's wrong. There's a part of my laboratory, the GCMS, in the lab in Ecuador. Here's our GC in the lab in St. Mary's. Here's the Idaho Blue Spruce. We did this the entire month of distilling and pulling samples every 15 minutes and analyzing it until we knew where we needed to be. Every 15 minutes. And that's why I built the lab in St. Mary's, because we're going to continue growing there. I need to be able to distill, I need to analyze, and in an hour and a half have the results to know what I need to do. But last year I didn't have it, year before last, and so I had to send the oils FedEx to Utah, wait to get the results back to determine when do we distill next. What's the proper cutting time? What's the drying time, maturing time? There's so much to it that people don't know and understand. Here's Dorado Azul that I did back in 2008 as I started really looking at the chemistry of Dorado Azul and what values does it have. And here's Dorado Azul when we look at the differences, and you can see the compounds there. This is when it's distilled dry, this is when it's distilled green. Same plant, just a different, actually it was only 1 week difference between the field dry and the field green. 1 week difference from field to field. Same plant, same week, 1 week difference in the harvesting and the distillation, and you see the variances in the compounds there. 1 week difference. So does it make a difference when you cut? Absolutely. How do I know it? Because I do it. I don't talk about it, I do it. Monstranti, another oil, a new one that you're going to have showing up on your doorstep one day soon. Beautiful. Oh my goodness. I've been developing this plant now for 4 years, and our field's growing and expanding, and we're almost there. Next year we'll be at it. So there again, studying the different distillation times, the different drying times. See when is the right time, because Monstranti had never been distilled until I distilled it. We have to learn. GCs, okay? I had a lady the other day posted me on my Facebook and says, well, this other company sends out their GCs, how come Young Living doesn't? I posted her back and I said, would you know how to read it if I did? Come on. Anybody can do anything they want with a GC. I can manipulate that if I want to. Or I can put a synthetic molecule in that injection port and I can create whatever I want there. So just having a GC printout is a joke unless you're an analytical chemist and you know how to read it. Is there anybody in this room that can look at that and tell me what they're looking at? I rest my case. Okay? I and you that have been in Young Living for a while know there are no secrets with Gary. I'm an open book and I live in a glass house. Okay? Helichrysum. There's one accepted, one rejected. You know what was interesting? When I rejected the one in red there, the competitor company bought it. And then said it was certified pure. What is the condition of the soil? Can you grow lavender at 5-point pH? Can you grow frankincense Ferion in Oman? Can you grow ylang-ylang in Idaho? The answer is yes, absolutely. You can grow anything anywhere. It doesn't mean it's going to produce an oil, all right? Another factor, and this is something that I discovered that is really an interesting science. There's a whole difference with the plants and with oil production based on longitude north and south, 80 degrees west, longitude north and south, 45 degrees east. So when I divide the globe, and now I'm taking this into a deeper science because I'm watching this and it's becoming very fascinating. Latitude east and west, 15 degrees south. Latitude east-west, 0 degrees, which is Ecuador. The equator, Tropic of Cancer, north, 45th parallel. Tropic Cancer, south, 45th parallel. So the 45th parallel, where does it run? Just north of the Utah border, about 100 miles. So every peppermint grower that grows north of the 45th parallel has to harvest at a different time, and they're also at a different elevation if they want to produce menthol. Below the 45th parallel at a higher elevation, you distill at a different time and a different cutting time of the plant to get a higher menthol level. And I was the first in the world to discover this. Why? Because of distilling every day for weeks at a time to identify when it comes in at. So we're not just doing research about something, I'm researching every fraction of your oil to find where you have the best. And I will not quit. Okay? The factor was not taken into equation until I started distilling in 10 different countries: France, Washington, Idaho, Utah, Ecuador, Peru, Oman, Egypt, Taiwan, and Israel, where I have actually conducted distillation myself. I've distilled in more countries than any, probably 100 people in the world today. North of the Tropic of Cancer, north of the 45th parallel, Washington, Idaho, south of the 45th parallel, Utah, south. It changes the chemistry of the plant. Why? Part of it is because of elevation variations, but part of it is because of the angle of the UV rays. Doesn't that make sense? A 5-year-old kid would know that, but it took me 60 years to learn it. Then you factor the elevation. Washington, north of the 45th parallel, elevation 1,500 to 2,500 feet. Distilling time for peppermint is early August. Below the 45th parallel, 4,800 feet to 5,000 where we grow peppermint, the best distilling time is the end of August to September to get higher levels of methone. Hot humidity climates in South America, shade drying and maturing. Dorado Sul immediately after cutting. Ruta, 5 days. Oregano, 5 days. Lemongrass, 3. Vetiver, 7 to 10, depending on the humidity and the barometric pressure. So I watch my weather station. I watch my weather reports to know what is right. And then we follow with bricks so I can build a volume. I'm writing a book on how to grow and how to harvest and how to distill. It'll be the most complete book ever published in the world on distillation. Eucalyptus, 3 to 5 days after picking. Ylang-ylang, immediately after picking. Ocotea, 10 days after picking. Palo Santo, 5 years after the tree's dead. Common adulterating agents found in peppermint, rose, sandalwood, ylang-ylang, clary sage, geranium. All of these agents are there. This is a letter that was sent to me. Dear sir, I'm a French exporter who expects products from Provence. I select very typical products with quality. Listen, which quality is unquestionable? I'd like to know if you would interested in provincial products like lavender essential oil, made in France. 50% lavender, 50% lavandin, 100% pure. I get these letters all the time. Synthetic or adulterating oils, mislabeling, dilution, adulteration can occur at any point in any production process. Eucalyptus, accepted and rejected. Why? Because the compounds don't meet my standard. Synthetic myrrh, Gary goes where it grows for no other personal adventure. That's why I know what we have cannot be questioned. Ethiopian papyrifia. How do I know? Who took that picture? The forbidden zone in central Yemen. I am the first foreigner to go in there in 40 years. And I'll bet you can't tell which one is me. Look at the ankles and it'll... Okay. The Ham Hill Plateau, Socotra Island, frankincense trees. This is where our sweet myrrh is coming from now, Socotra Island. Why? Because I went there twice to find it and make the arrangements with the people for gathering it and shipping it. In the Forbidden Zone, following the frankincense trail. The Alhasik Mountains, Oman, researching the frankincense sacra. Again, in the mountains, looking for frankincense sacra. Myrrh tree in Yemen. I've made 8 expeditions into the jungle, into the Amazon jungle in Ecuador alone, looking for plants, and so far I have found 42 plants in Ecuador that have not been identified, that I've distilled oil from. I've made 3 expeditions into Peru looking for plants. I've now collected 6 plants in Peru jungle that have not been identified. Oils produced by the Young Living Farms. Young Living controls all the steps of production of oils from seed to still. Gary has invested 33 years in research development of essential oils. Young Living has 28 years in the development discovery of essential oils for natural medical supplementation. Young Living has 24 years in farming, distillation, analytical evaluation of the study of essential oils. Young Living has 9 farms and over 14 partners, wildcrafting and distilling worldwide. No other company in the world has a history of research and development or has brought as much to the world as Young Living, the world leader in essential oils. Who has brought more research, education, discovery, published more papers, more books, created more formulas and supplements with essential oils than Young Living? Not 1, not 10 companies combined. Who is the best choice for your future to become a partner with? I'll let you decide. Thank you, thank you. God bless you.